In today's video, I'll be setting up a 5G whole home backup internet connection that I can fail over to automatically if my main fibre connection ever goes down. And I'll be doing it using this really interesting Teltonika RUTC50 router. We'll take a quick run through of my plans and requirements, take an in-depth look at the hardware we'll be using, run through the software configuration, and then finally jump up in the attic and get this all installed and set up. But first, I'd like to thank MS-DIST for sponsoring this video by providing the Teltonika router we'll be using for this project. MS-DIST is an official distributor and reseller for Teltonika, along with other brands including MikroTik and Ubiquiti. They offer competitive pricing, including special pricing for trade customers, and have product experts available if you need an extra hand picking the right product or after-sales support. So, if you're interested in buying any of the hardware you've seen in this video, or any other networking hardware for that matter, definitely check them out, and I'll leave links to all the products shown in this video along with a discount code for MS-DIST in the video description and in a pinned comment. So first up, let's run through my plans and requirements for this setup. What I want here is an always-on 5G backup internet connection that my router will automatically fail over to if my main fibre connection ever goes down. And I want this for a couple of reasons. First of all, in the modern world of working from home as well as everything being so reliant on a stable internet connection, I want the safety net of having a backup connection. Additionally, if you've seen my other videos, you'll have seen that I spent a ton of time and effort installing a fancy CCTV and alarm system that's accessible for me to monitor remotely. But this system has one glaring vulnerability. It all runs over a single fibre internet connection, and the fibre is very conveniently exposed on the front of the house in a nice labelled box. This means that someone could easily defeat my alarm and CCTV system simply by cutting this fibre, which isn't ideal. Now, I imagine this isn't particularly likely, and I've never heard of it really happening, but it's definitely something to think about. So, by installing a backup connection using hardware securely mounted inside the house, I essentially get rid of that risk. The other requirement I have for the setup is that I want this to work with my existing router, which is currently a MikroTik RB5009. I want something that I can just connect in the exact same way as if it was a second fibre connection and have it work as a backup internet connection. I didn't want a solution where I'd have to replace my router with a specific 5G model or anything like that. I also wanted a solution that would allow me to directly pass the public IP address of the 5G connection directly through to my router to allow things like port forwards and VPN connections to work. This ruled out the vast majority of basic consumer 5G router devices, as these would introduce double NAT. I needed something that would work essentially like a completely transparent modem. So that brought me onto Teltonika devices, and in particular the RUTC50 that I have here. If you haven't heard of Teltonika, they're a pretty interesting brand of pretty high-end networking hardware. But rather than targeting your traditional office and data centre market, they instead target more embedded and industrial environments and offer a really interesting and flexible range of hardware. If you're looking for a router to install in a vehicle or some sort of industrial or embedded equipment such as those mobile CCTV towers or something like a remote train ticket machine, these are the sorts of devices you would want to use. But of course, they're also equally at home in homes, offices and all sorts of usual places like that. And while Teltonika do offer several models of standard wired routers and things like switches, the vast majority of their products include a really powerful mobile data modem, which is what we'll be focusing on here. When it comes to picking a Teltonika router, they have a ton of different models with various connectivity options to pick from. But for my setup here, the main consideration was getting something with the fastest 5G modem possible. You'll see this described as an LTE category, with different category numbers defining the maximum upload and download speeds possible. This is important to check, since many models are designed for those simpler embedded IoT and telemetry applications where high speeds aren't as huge a consideration. So for a whole home backup, you'd want to make sure you get something that can handle the speeds that you need. And that's why I opted to go for this RUTC50 model, since this has a category 20 modem allowing for theoretical speeds of up to 2 gigabits download and 200 megabits upload. Now of course, I'm unlikely to get anywhere close to that with my setup since I'll be connecting to this over gigabit Ethernet ports, and I'm also currently in a very poor coverage area, but I wanted something that would get me the highest speeds possible, especially once the 5G coverage in this area hopefully improves. So, here we have the RUTC50, and this is a full-blown router with a built-in Cat20 5G modem, gigabit Ethernet and Wi-Fi 6. Software-wise, it runs Teltonika's RUTC5050, which is based on OpenWRT, so it's pretty powerful, including support for tons of different VPN protocols, including things like zero-tier. Of course, for my setup here, I'm just going to be using this as a simple modem, but if instead you wanted an all-in-one 5G router, this is definitely a great option. Taking a closer look at the router, we can see it's a pretty compact unit, and you can very much tell it's designed for more of an industrial or embedded application instead of being a more traditional rack mount device. It's a completely metal enclosure that's all passively cooled using the heat sinking all around the outside of it. On the front of the router, we can see we have 5 gigabit Ethernet ports, 4 of which are designated as LAN ports and 1 WAN port, which you could use for a hardwired internet connection. This means that if you're using this as a standalone router, you could connect your primary fibre connection into the WAN port and then have this automatically handle the failover to 5G if that fibre connection ever went down. Above this, we then have a pair of SIM card slots, meaning that you can install multiple SIM cards. You can either switch between them manually or set up various conditions in the software that will cause the router to automatically switch to another SIM, such as this a weak signal on the primary SIM, or maybe if you're roaming in a different country and things like that. Some SKUs of this router also support installing an eSIM in addition to physical SIMs, but that's not the model I have here, so you need to make sure you buy the appropriate model if you want eSIM support. Then we have a bunch of different LEDs to reflect the SIM status. These ones above the slots here show which mobile network standard the SIM is connected to, so 3G, 4G and 5G, and this one here gives a rough idea of the signal strength. Then these LEDs over here show the various status of each of your WAN connections, so your different SIM cards, your Wi-Fi if you're using the Wi-Fi for a WAN, and the Ethernet WAN connection. And then finally down here we have a couple of LEDs just showing the status of the built-in Wi-Fi, both on the 2.4 GHz and 5 GHz bands. Then finally on the front we have the power jack. And this is where the industrial roots of these routers really shows through, since they're very flexible when it comes to different powering options. In the box you get a standard 12 volt power adapter, so you can just use this to plug it in, and you can plug it into the wall and plug that into the power jack on the front of the router. But as you can see by this diagram on the top of the router, this can be powered by anywhere from 9 to 50 volts DC. Teltonika also sell a range of different power cable options, ranging from AC adapters such as this one, all the way through to power cables that just break out to screw terminals, allowing you to wire it into some sort of external DC power supply. In fact, they even just sell the connectors on their own, allowing you to make up your own cables. On this diagram here, you can see that the connector has 4 pins. Positive DC voltage and ground, which is used to power the router, but we have these additional 2 input and output pins. And these act as GPIO terminals that can be controlled through the router's operating system. The input pin will sense any voltage between 0 and 6 volts as a logical low, and any voltages above 8 volts up to a maximum of the supply voltage will be sensed as a logical high. Then the output pin outputs a switchable 30 volt DC signal. Of course, I don't have a use for this in my setup, but it could be pretty useful if you're integrating this as part of some sort of industrial system. You could, for example, use the input to sense whether you're running on mains or battery power, or use the output to power cycle an external piece of equipment. So, that's a DC power input. But there's one other powering option that you might be expecting, but unfortunately support on Teltonika devices is pretty spotty. And that is power over Ethernet. A large number of Teltonika devices do support PoE. However, it's usually what's known as passive PoE, meaning that it expects to be connected to a PoE injector or switch that's permanently outputting power on its ports. Most modern PoE switches instead use active PoE based around standards such as 802.3 AF and AT. With these switches, the connected device needs to first communicate with the switch to negotiate power before the power is turned on. Of course, there are still solutions to this. Some PoE switches will let you force a particular port to output passive PoE, or you can use an external PoE injector. However, I prefer to avoid doing this, since it introduces the risk of you forgetting that you've configured a port for passive PoE, plugging that port into a device that doesn't support PoE, and ending up damaging the device's network interface. And I've seen this happen quite a few times. Another option that I prefer when it comes to powering passive PoE devices from an active PoE switch is using a simple PoE converter mounted directly next to the device that's being powered. These simply connect in line with the Ethernet cable, negotiate PoE from the switch, and then convert it to passive PoE at a particular voltage, which is then passed to the device that you're wanting to power. The benefit of these is that you can locate them directly next to the device that's being powered, meaning you no longer have the risk of passive PoE cables running through your building. However, when it comes to the RUTC50 in particular, PoE support gets even more tricky, since PoE support on this model depends on the particular hardware revision. Models newer than hardware revision 0303 and batch number 007 support being powered via passive PoE on LAN port 1, with voltages between 9 and 50 volts. However, models from before this don't, and the unit I have here is unfortunately one of those models that doesn't support passive PoE. However, it's not the end of the world. Since I'd have needed some sort of external converter to output passive PoE anyway, I can simply power it using one of these inexpensive PoE splitter devices. They're pretty inexpensive and they're super useful. You simply connect them to PoE on the input port here, and then the output Ethernet without power on this port here, and then output power through a separate DC jack. You can get these in various different form factors with different output voltages and connectors. In fact, I'm already using one of these to power my fibre ONT over PoE, and you can even get ones that allow you to convert PoE to USB power. For this setup here, I've opted to go for the slightly fancier model just because it has mounting holes, which will make it easier to install. It has an input port here, which will connect down to my main router, which will output power over PoE using active PoE, and then it has an output port here that will output the network without power, and then a DC barrel jack that will output power to the Teltonika. This also has a switchable voltage. It can go anywhere between 5 and 18 volts. The Teltonika needs between 9 and 50 volts, so really any of these voltages bar 5 volts will be fine. I'll just leave it on 18 volts because the highest voltage will be presumably lower current on the output jack. But yep, that's what I'm going to use to power this. Of course, we're going to need some sort of way to connect the barrel jack on this to the Teltonika's DC input. As I mentioned earlier, Teltonika sell various different power cables and adapters. However, this is actually a standard connector known as a Molex MikroFit 3.0. So what I ended up doing was just buying a MikroFit to MikroFit cable, so it was this sort of cable, 4 wires with the same connector on both ends. I then ended up cutting it in half, and because I'm not going to use the input and output pins, I just removed those wires from the connector, just giving me a connector going to 2 wires, and then I just wired that into this screw terminal DC jack here. Of course, if I wanted to use the GPIO input and output pins, I could also just use this connector here with all the additional wires, and I could use the second black and the yellow wires as the input and output. So for my setup here, all I need to do is, I've got a Teltonika router there, I can take my cable here, I can connect the Molex connector into the power jack on the router like that, and then plug the DC jack into my PoE splitter like that, and that'll work. Of course, there's tons of different options out there when it comes to PoE splitters and suitable cables, but I'll leave links to the ones I've used here in the video description. So, that was the various powering options. But there's one more thing on this router that we haven't looked at yet, and it's all of the antenna connections on the other side. As you can see, we have connectors for an absolute ton of different antennas. We have connectors up here for up to 4 antennas for the mobile network, 3 down here for Wi-Fi, and an additional connector in the middle here for GPS. In the box, it comes with all the antennas you could need. You get 4 of these mobile data whip antennas and 3 of these Wi-Fi antennas. Interestingly, the Wi-Fi antennas are cabled, so you need to kind of mount them somewhere separate from the router, and the same goes for the included GPS antenna. For my setup here, all I'm going to need is the 4 included mobile data antennas, and the included ones will be absolutely fine. But you aren't limited to the included antennas. There's absolutely tons of third-party antennas you can use with routers like this, including massive external mobile data antennas, which could be ideal if you want to get the best signal possible. Some of these can even be installed outside on poles outside a building high up, really lots of different options to get the best signal possible. MS Dist also sell a large range of these different antennas, so definitely check them out if you're wanting something a bit more than the included antennas. Then finally on the back we have a USB port, which you can use to connect storage devices, or apparently you can also use this with USB to serial adapters to allow this to control other devices over serial. So, that was a tour of the router itself. Now the only thing we need to figure out next is how we're going to mount it. And for this, Teltonika offer a range of different options. My plan here is to simply screw this into a board in my attic, so I've opted to go for the simple surface mount kit here. But they offer a bunch of different options, including brackets to mount the router on a DIN rail, so if you wanted to install it in some sort of industrial cabinet, you could do that. The mounting bracket I've gone with here simply screws into the router into various different slots. So the router has 3 different slots on it. It's got one on the top, one on the bottom, and then one on the back here. So you can kind of pick which slot you want to use and mount your mounting bracket into that. And there we go, that's the mounting bracket now installed. So when I install this in the attic, I can simply screw it to the board using these 2 screw holes here and here. One thing I noticed with this is when you're installing it on the router, essentially what you've got is these slots here, here, and here. And the screw that comes with the bracket almost sort of just taps a thread into that and then fixes it on. Only thing to bear in mind is these sort of slots here look very similar, but these are slightly closer together than this, and these are really just for heat sinking. So if you're mounting the bracket onto the back of this router, you need to make sure you use this slot here. These ones here, you can kind of shove the bracket in and it maybe does fit, but you'd probably end up chewing it all up if you try to put a screw in. So you just need to remember that this one here is the one that's for the mounting bracket. The DIN rail brackets are basically the same. They screw in the exact same way, but they give you a DIN rail clip instead of these kind of screw lugs that stick out from the front of the router. But yep, that's now ready to mount. And there we go, I've also just attached all the antennas, so I've just put the mobile ones on, that's the only ones I need. They're all screwed into the back. Only thing to bear in mind is that this GPS connection is in the middle of between the 4 mobile ones, so you need to make sure you kind of skip over that when you're installing the mobile ones. And I might try installing the GPS one, see what I can do with it really. The Wi-Fi connections are then down here. These are a reverse polarity to the other ones, so you can't get these 2 mixed up, but you could kind of mix up the mobile and GPS, so just be careful with that. But yep, that's all the antennas installed as well. So that was the hardware. But now there's one final thing that we need to do before we can set this up, and that is that we need to install a SIM card. And of course, there's tons of different options you could go with. If you're using this as your primary internet connection, it's pretty simple, since you just want to go for a monthly data contract that has a high enough allowance to cope with your usage. However, for a backup connection, things get a bit trickier, since most of the time you're barely going to use it, but if you fail over to it, then you may need to use a significant amount of data. Of course, one option is to simply go with a plan that has enough data to handle the largest outage that you can predict. And that'll work, but you'll likely end up paying for loads of data that you won't use most months. Another option is to go with a provider that has a concept of either buying data add-ons in addition to your monthly allowance, or plans that allow you to roll your unused data allowance onto future months. With these, you could pay for a small amount of data every month, and then top up whenever you need more during an outage. However, there's a third option, and that's what I've gone for here, and it's what are known as preloaded data SIMs. There's a range of these available, and I found one of the best places to buy them is actually Amazon. These come with a preloaded amount of data allowance that will last for a predetermined amount of time. The cost then depends on both how long the data SIM will last for, as long with how much data you opted for. And these seem ideal for a backup connection, since the SIM I went for here cost £65 for 500 gigabytes of data that will last for up to a year. This means that while most months I'll probably barely use it, if there's a large outage and I need to rely on the backup connection for an extended period of time, I'll have a huge 500 gigabyte allowance available to use. Of course, if you're doing something like this yourself, you'll really need to go away and work out what sort of data plan works best for you. But these preloaded SIMs seem like a great option, and I'll leave links to the one I went for in the video description. So yep, that's the SIM I've gone for, so all we need to now do is install it. So it comes with a couple of different adapters for different sizes of SIMs, as well as a SIM removal tool. So all we need to do is take the SIM removal tool, pop out one of the SIM trays. I'll just use slot 1 because we're only installing one SIM in this. SIM tray then just comes out like that. It's quite a nice substantial chunky SIM tray compared to what you're going to get in a phone, so it's quite robust, which is good. And then we get the SIM installed in that and fire this up. And there we go, the SIM is now installed in the tray, so we can just take that, slide it into the front of the router. The tray goes a little bit further back than the front of the router, so just make sure it's pushed in all the way. And that's the SIM now installed. And with that, the router is now ready to go. So now let's fire this up, take a look at the software side of things, and then we'll finally go away and get this installed in the attic. Okay, so now let's run through the software side of things. So here we have the router set up, so I've just plugged it into power with the power adapter for now, and then the LAN port on the Teltonika is plugged into one of the network ports on this PC here, and this is the PC you're looking at. And out of the box, using its standard configuration, the Teltonika works like a standard router and assigns the computer an IP address over DHCP. So we have a local IP address assigned here over DHCP, and if we go to 192.168.1.1 in the browser and log in, there's a default password set on the bottom, printed on the bottom of the router, and then it asks you to change it when you log in. So you log in here, and here we are in the Teltonika web interface. Now, I'm not going to go into do a full tour of this. There's loads of stuff in here, and it has most of the stuff that a normal router would have. And the Teltonika docs are really, really comprehensive. But as you can see in here, it's got a ton of different options. You've got your status for all your different things to sort of view status. You've got configuration for all your different network options, your WAN, your LAN, your mobile data. Various things around VLAN, routing, firewalling, all that kind of stuff. There's also a services section, which includes things like all the different VPN services it supports. There's tons of functionality in here. It even supports things like MQTT for remote monitoring and that sort of stuff. It is extremely powerful. But what we'll do in this video is we're just going to focus on the functionality that I'm going to be using for this setup here, which is mostly the mobile data setup. First of all, we have this sort of status page here. This shows the basic connectivity, shows that we are connected to the internal modem. We're on 4G plus currently. The signal here is not very good, so we're in a room that's got kind of foil-lined plasterboard walls. The signal's really poor. Hopefully it'll improve when we get up to the attic. Other stuff in here, we can see we've got the Wi-Fi connection here that's set up by default and stuff like that. But yep, we are all set up and working. So first thing we can see is the status. So we've got all different options here. We can go to the mobile network status first, and this shows us the status of our currently connected mobile network. See all different information. I'll blur a lot of this out because it's data about my SIM card. But you can see all different information, the various sort of standards of network connectivity it's using, all that sort of stuff up here. And then further down the page here, we can see a bunch of other information. We can see the sort of signal strength, APN, different information about network connectivity, loads of information about the cell connectivity. I don't understand a lot of this stuff, but you can kind of look up what tower you're connected to, all this sort of stuff, all different bands you're connected to. Again, right now, we're in a very poor signal area in this room, so the signal is not great. We're only getting a couple of little bands in here, nothing particularly high bandwidth, but hopefully this will improve when it's in the attic. But you can kind of see all the information about the signal status, which is really good. It means if you've got any sort of weird issues, you want to diagnose things, there's a ton of information coming out of this. So yeah, this is kind of your network status for the mobile network. There's other sections in here for settings for status on all your other network, your firewall, your LAN, all that kind of stuff. But the main thing we're going to take a look at now is how we're going to configure all this. So We go to the network section here. This gives us a few different options to configure. We first of all have the mobile section up here. This lets us configure our mobile networks. This is more configuration around the mobile data modem itself. So things like your roaming, if you have a PIN on your SIM card, different options in here for different types of network types, your 5G modes, different bands you want to set, what to do about low signals. You can set things around data limits, so you can set data limits on each of your SIMs. In here you can define how it switches between SIMs, so we can go into here, we can change settings on this, and this lets us define when it's going to switch from SIM 1 to SIM 2. So you can do it if it's a weak signal, if a SIM hits its data limit, if it hits an SMS limit, if you're roaming, if there's no network, loads of different options here. And then in the utility section here, we can see a bunch of other things, enable flight mode, that kind of stuff. And it also gives an option to send USSD codes. These are those codes you might have ever used on a phone to view things like your IMEI number, where you have to kind of enter like star, a number, and then a hash. You can enter them into here and it can send those out to the mobile network. And these may be useful for configuring things. It really depends on your different network provider, but you might be able to use this sort of send commands to your mobile provider if your net provider supports that. So this is more the kind of mobile sort of modem configuration. Then we have the more network side of things, and this is in the WAN section here. And here we can see our different WAN interfaces. We have IPv6 and IPv4 WAN connections for the physical LAN or physical Ethernet port. We aren't using these. And then we have the connections for our two mobile data connections. We have this one here that's currently running, and we can see a bunch of information, and we can see here that we're given an IP address. Now, this is mostly the default configuration, and that generally works and is suitable for my setup. But there's one thing here we are going to need to change, and that is that, as you can see here, we're currently being assigned an internal IP address by the mobile data provider. This will vary between providers, but with the provider I'm using here, which is 3, as sort of by default, they just give you an internal IP address and use carrier grade NAT. This means that a single public IP address is shared across multiple clients, and each client then gets given a sort of internal IP address. Now, for a phone, that's going to be completely fine. But for a setup like this, where I'm potentially going to want to port forward, I want to connect into the house remotely over a VPN, using a VPN server that runs on my router, this isn't going to work. I'm going to need a public IP address. Thankfully with 3, this is quite easy to change, and they do offer it. So right now we can see the APN, which is kind of the access point name. It's a name you need to give to connect a mobile network. This is just set to auto, and by default it picks up the standard one, which is just 3.co.uk. We can change this, however, and if we go into edit, turn off auto APN, and we can change the APN to a custom one, which is 3 internet. And on the 3 network, if you set that APN to 3 internet and save that, wait a little second, it'll take a little second to reconnect the network, and with this new APN set, we should reconnect and be given our own public IP address. And there we go, took a few seconds, we're now reconnected, and now we have our own public IPv4 address. Of course, this is still a dynamic IP address, it'll still change from time to time, but at least it's a public IP address, so I can port forward through that. And on my router, I'll be running a dynamic DNS service that I use anyway, so that'll automatically handle switching between my main fibre internet connection's IP address and my backup internet connection automatically using that dynamic DNS service. And likewise, that will also handle the IP address of this connection changing from time to time. So with that now set up, we now have a public IPv4 address, and we're basically ready to go. And with that, we're almost good to go. However, right now, this Teltonika device is still acting like a normal router. It's broadcasting a Wi-Fi network, and it's performing NAT between the public internet IP on the internet connection on the mobile data connection and my computer here. So if we take a look in the Windows network settings, we can see here that we're being assigned an IP address in an internal subnet. When I connect this into my main router and want to use it as a backup connection, I don't want this. I want the router to be assigned the public IP address of the mobile data connection. But thanks with Teltonika, this is actually really easy to set up. If we go back into mobile data settings here like before, there's this option here for mode. And currently this is set to NAT. And when this is set to NAT, it simply works like a standard router, performs NAT, and assigns clients an internal IP address. But there's these 2 other options here called bridge and pass-through. And both of these are very similar, and they allow you to pass that public IP address of your mobile data connection through to the connected client. There is a subtle difference between the 2 of these, and the documentation isn't particularly great, but my understanding is that bridge mode essentially passes the IP address directly through, and it turns this into a completely transparent modem. And in doing that, the Teltonika router itself and any other clients connected to it no longer have an internet connection. On the other hand, pass-through mode is kind of a bit like a one-to-one NAT almost, in that it does pass through the public IP address of the mobile data connection, but the router itself still maintains its own internet connection. And it seems that pass-through, essentially, the router itself almost gives a DHCP lease to the client of your public IP address, whereas bridge mode just forwards the DHCP itself from your WAN connection to your connected client. Now, because this is I want a simple setup as possible, I don't need the router to have an internet connection. I'm just going to go with bridge mode because that just keeps things simple. And what this means is that the first client that connects to this router will be given the public IP address of the 5G connection. There's other options down here as well. The main one here is MAC address. This is the MAC address of the client that we want to give the public IP address to. If this is left empty, it'll work absolutely fine and it'll just give the public IP address to whatever client connects to the router first. And that's what I'm going to do here. But if you wanted to, you could specify a single MAC address in here, and that is the MAC address it will give the public IP address to. So if multiple devices were ever connected to this router, it'll only give the public IP to the one that you want it to. But as I said, for my setup, this is going to plug directly into my router, so I'm happy just to leave that blank. And now with this set, we can save that, and now this will run in bridge mode and pass through the public IP address of my internet connection through to this computer. And now with that change made and everything kind of reconnected to the network, we can come back into the IP address settings here on Windows, and we can see that now I have a public IPv4 address. So the IP address of my internet connection is being passed through directly to this computer here. So if instead of this computer this was my router, it would give my router a public IP address and work just like a transparent modem. So yep, as we can see, we now have a public IP address, and this is exactly what I wanted to set up. This is now working as a transparent modem. Now at this point, the downside here is now because you've got this public IP address, you're going to have issues accessing the Teltonika's web interface. Now, weirdly with the setup here, using a Windows machine and just having a single device, I can still access the Teltonika's web interface just by going to 192.168.1.1. I don't quite know how it's doing that. I suspect because this is the default route and this is the only internet connection this machine has, obviously any traffic, any requests to that IP address are being sent to the Teltonika, and it's grabbing that and it's working. If on the other hand you were using this as a secondary connection and therefore it's not your default gateway, what you would probably need to do is set up a static IP address on the interface that's connected to this router in the 192.168.1 subnet. So you would have it set up to use DHCP for your main IP, which would get your public IP, and then add a secondary IP, and that would be the IP address in this subnet, and then that would allow you to access the Teltonika's web interface. You may need to set up some sort of routes and firewall rules in your router to allow that as well. But yeah, with this setup, if you do that additional configuration, you can still come in here and access the Teltonika interface. This is quite important, since especially with these preloaded data sims, there isn't a way to view your current usage. So at least here the router is collecting that, and we can sort of use that data and maybe be able to even pull it off programmatically and monitor it somewhere. But yep, you can still access the web interface when you're using it in bridge mode. You might just need to set some static IP addresses on your network interfaces, depending on how it's all set up. But yep, that's now working. So of course, what we have here works, and we're now giving this Windows machine a public IP address. Of course, that's not really what I want to be doing, and probably isn't a particularly good idea with this being a Windows machine with a public IP address and no firewall. But what I really need to do now is get this connected up to my main router and set it up as a backup connection. So what I'll do is I'll go away, get all that configured, figure out all the MikroTik Router OS configuration, and we'll come back and take a quick look at that configuration. But there's one final thing I want to do before we do that, and that is that right now this is still broadcasting Wi-Fi. It's still got the Wi-Fi enabled, which of course we don't want. So all we need to do that is go into network, go into wireless, and in here we should just be able to go in here and just turn off the Wi-Fi, and that will disable the built-in Wi-Fi. And now this is working as a completely wired, completely transparent modem. Okay, so I've now done the MikroTik configuration, so now my router is set up to automatically fail over to the internet connection coming from the Teltonika. So just to quickly explain the sort of test setup here, like before we have the PC, but this is now connected directly into my main network, and then this network port on the wall here with the purple cable is essentially patched through to the second WAN port on my MikroTik router, so Ethernet 2 on that is patched directly to this port. This is then connected to our PoE splitter, so this is getting PoE from the MikroTik RB5009 router. That's then splitting out into the power cable to power the Teltonika, and then the LAN port, LAN 1 on the Teltonika is plugged into this. So essentially from a network perspective, LAN 1 on the Teltonika is plugged into Ethernet 2 on the MikroTik router. And this is the MikroTik router that we're looking at the configuration for here. So the first thing we need to do is set the MikroTik up so that it can get an IP address from the Teltonika router over DHCP. That's easy enough to do. We can just do that in the DHCP client section. We have a single DHCP client added here. It's on the Ethernet 2 interface, which is what's plugged into Teltonika. That's set up, and with that configured, we automatically get an IP address from the Teltonika. And as you can see, because we set the APN correctly, the MikroTik router is getting a public IPv4 address. And that's working. Of course, as I mentioned, I also want the ability to access the Teltonika router's management from my main network. So because that's not in the same subnet as this public IP, what I've needed to do is add a second IP address to the MikroTik, which you can see here, which I've added to the same interface that's connected to the Teltonika router, so to Ethernet 2. And I've just added a static IP address in the same subnet as the Teltonika's IP. So the Teltonika is 192.168.1.1, so I've just added 192.168.1.10 to the MikroTik. Of course, this might conflict with something on your existing network. If that was an issue, all you would need to do is change the IP address on the Teltonika router to be in a different subnet and use that subnet instead. I might still do that just in case I ever change stuff in the future and need that subnet, but right now this works absolutely fine. So right now I'm connected up through this internet connection, but I've not failed over to this. I'm still using my main internet connection, but I'm connected up to the network through the MikroTik. And if I go into a browser and go to 192.168.1.1, we can pull up the Teltonika's web interface, even though I'm now connecting via my main network. So I can still access this to manage it and get stats and all that kind of stuff. So yeah, that's all set up and working. But we need to figure out a way to set up the failover. Now, the simplest way to do that is just with the root distance. So as you can see, we have our DHCP client here, and this is getting an IP address from the Teltonika. If we go into settings on this, we have an option here to say we want to add a default route. So we say we want to add a default route from this, and we can change the default route distance to 2. What that means is that my main internet connection has a route distance of 1. That's set up in the PoE client settings. We set this to 2 for the DHCP server or DHCP client on this router, and that then means that the route to the internet via this router has a higher distance, and that means it won't take priority. With that set up, what then happens is I will normally use my main internet connection, but if that route goes down, it will automatically fall over to the route with the next lowest distance, which is this one, and that'll work. And with that, you'll have pretty decent failover. However, it's not the best sort of setup you could have, because you could fairly easily have a situation where maybe there's an issue at my main ISP where they're not able to route out to the internet, but my connection between my router and my ISP, so the PoE connection, remains up, but they're not able to route out to the internet. In that situation, just relying on the default route distance won't really help, because as long as the route to my main ISP is up, it will still prefer and try and use that route, even if it's not able to route out to the internet because of an issue at the ISP's end. MikroTik do have a solution for this, and it's described on this documentation page here. I'm not going to go into a full amount of detail and try and explain this in this video because it's probably a hour long video in itself. But essentially what they've got is some configuration here that you set up, some weird sort of recursive routing, and the idea is that you have 2 separate public IP addresses that you want to monitor, one that's monitored by your primary internet connection and one that's monitored by your secondary internet connection. And if one of those public IP addresses becomes unreachable via its respective internet connection, your MikroTik router will class that route as down and fail over to the other internet connection. So with their configuration here, they're using Google's public DNS. So on their primary WAN, they're pinging 8.8.8.8. On their secondary WAN, they're pinging 8.8.4.4. And if either of those is unreachable via their respective internet connection, it will fail over. This just means that if your, say, PoE session remains up, but your ISP is unable to route out to the internet, you will still automatically fail over. I've essentially configured the same thing on my internet connection here. If we go back over to Winbox and look at the MikroTik configuration, we've essentially got that set up in the root settings. So we go into our static routes. We've got 8.8.8.8 monitored via PoE out 1, which is my fibre internet connection, and the respective default route for that. And that all works. Similarly, we've got routes here for 1.1.1.1. This is essentially what they're discussing down here, where they're essentially talking about monitoring a second IP address as well. So if, say, Google's public DNS goes down, but my ISP is still up, I won't fail over. So for me to fail over to my secondary internet connection, both 1.1.1.1 and 8.8.8.8 would have to be unreachable via my fibre connection before I fail over. You may notice here that I'm not doing what they're doing and also checking the internet reachability of the second internet connection. Now, the reason for that is because I'm using DHCP to assign an IP address from the Teltonika to the MikroTik. That gets very tricky with this setup, because you can't just specify a gateway interface like I'm doing here with PoE out 1. You would have to specify the actual gateway IP address and that's set dynamically and could change. You could get around this by potentially building some sort of script that runs on the router, on the MikroTik router, that works out what the gateway IP address for the secondary internet connection is and automatically updates the relevant static routes. But for my setup here, it's not worth it. I don't have any real requirement to check that my secondary internet connection is up, because I'm only ever failing over to it if my primary connection's down. So if the primary connection's down and I fail over and the secondary connection's up, well, good, that's worked. If my primary connection's down and the secondary connection's down, well, that's fine. It's down. There's nothing I can do about it, so it doesn't matter if I fail over to it and it's down. So this works absolutely fine. Essentially, I'm doing exactly what MikroTik's described here, but only half of it. I'm only checking that my primary internet connection's up. I'm not monitoring if the second connection goes down or not, because it doesn't really matter. And at any rate, as soon as the primary internet connection comes back, I will automatically fail over back to it again. So yeah, this works. And if you want to find out more, check out MikroTik's videos on the topic, because they'll go into a lot more detail than me and probably understand it a lot better than I do. But yep, with this, I have a working failover connection. So what we'll do now is we'll quickly go up in the attic, get all this properly installed, and then we'll take a look at it working. Okay, so now here I am up in the attic, and I've already installed this bit of plywood here to install all the kit onto. And as you can see here, I've already got this network point here, so this is a pair of Cat6A runs that run from here, down all the cable basket you can see at the back that I've already got installed there, and that runs all the way down to the rack in the garage. So I've got these 2 points here that I can use. I end up using a bit of dado trunking. If you're using sort of surface boxes with this Cat6A and these angle modules, you kind of need to end up bringing a sort of a grommet at the top in conduit, because you can't come in the back, it just doesn't let you bend it around. So this dado trunking is quite a good compromise, because you can kind of come through the back, bend it around inside here, and then into this. And while I'm just going to be using PoE for now, I've left enough space here that if I want to install some sort of main socket here to have sort of mains power in this area, I could do that as well. But right now, we've just got the network. So as you can see, we've got our 2 network points here, AT01 and AT02, AT meaning attic. All we need to do now is connect the Teltonika router into one of these. So what I need to do is get the router mounted up along with the PoE splitter, get all that connected up, plug it into this, and we should be good to go. So there we go, that's all now mounted. So I've mounted the router over here, PoE splitter down here, the network down to the router then connects into the PoE splitter, and then out of the PoE splitter we have the DC connection going into DC input on the Teltonika, and then the data output of the PoE splitter goes into the LAN 1 on the Teltonika in there. This isn't pushed in all the way, so now when I push this in, it should all power up, and in theory, just works. Let's push that back in and see what happens. There we go. PoE splitter's powered up and is outputting 18 volts, and if you look down at Teltonika, we can see that it's starting up. And there you go, as we can see, the Teltonika's now booted up, and as you can see, we've got a mobile data connection. It's detected a 5G connection, so that's good. Signal strength's kind of middle. It's definitely not going to be a great signal, but yep, that's all now connected, so let's jump downstairs and see if this works. Okay, so now here we are down in the garage, and as you can see here, we've got the other end of that attic connection, so AT01, that's there, and then that goes into the second network interface on the router. So on the MikroTik router here, Ethernet 2 is connected to the backup connection there, and this green cable, which is Ethernet 1, goes up to here, and this carries PoE and data to my ONT under the stairs. So that's my main fibre connection coming in there into port 1, and then the backup connection is in port 2. Both connections are currently up and running, and down here we've got a laptop here just pinging out to the internet, and as you can see, we're pinging out the internet with the fibre connection, absolutely fine. That's just continuously pinging, absolutely fine. But now let's disconnect my fibre connection and see what happens. So I'm just going to unplug the fibre connection here, like that. That's now unplugged. Flew it down the laptop here. It should stop pinging. Yep, some request timeout coming in there. And straight away, we failed over. So you can see we failed over now. We're getting slightly higher latency because now we're on the mobile data connection. But yep, that's failed over perfectly. And it only took, what, a second or so? So now that it failed over, let's do a speed test. And this is the first time I've tried one, so no idea what sort of speeds we'll get, but let's see. So that's speed test there. Okay, we're getting about 25 to 30 meg. Nothing amazing, but it is a very weak signal in this area. That's way better than I can get on my phone, so that is still a pretty good connection. And that is completely usable for really any kind of backup applications. I could completely work off of that absolutely fine. Upload speeds are pretty low, like I wouldn't want to be uploading a video over that, but again, it's usable. It's about equivalent to kind of a DSL connection, and that would be fine in the event that I've completely lost my fibre connection. It is way better than having nothing. And similarly for things like the CCTV and alarm notifications, this is absolutely fine for getting those remotely. Oh, there we go, do another test now, and as you can see, we're now getting actually a bit faster, we're getting about 60 meg. So yeah, we're getting, 50, 60 meg. This also isn't the only thing in the house. Other stuff in the house is using the internet connection, so that will be congesting it a little bit. So yeah, the speeds are absolutely fine, completely usable for a backup connection. And as I said, the signal strength in this area is extremely poor. So this is definitely due to the coverage in the area, not the Teltonika. It can definitely go way faster than this. So yep, we've now failed over. We're now, as you can see, we've got latency here from the mobile connection. It's a bit more, it's fluctuating a little bit because it's a mobile connection. But now let's just test this. Let's plug my fibre back in, and hopefully it should re-establish a connection. Now, it won't be instant. It'll take a little while for it to connect, re-establish the PoE connection. But that's now plugged in there. We're still pinging out with a fibre connection, and eventually we should see it switch back, and the latency will drop back down to the sort of consistent 14 milliseconds or so we're getting on the fibre connection. And there we go, as you can see there, it dropped one packet, came back up, and now we're back on the fibre again. So yep, that fails over perfectly. Now of course, this example here was a fairly brutal unplugging the ONT, which completely brought this link down. That's also why it took a bit longer to come back up, because the ONT had to fully reboot, because this is PoE, so disconnect naturally powers the ONT down. However, of course, I set up that additional monitoring, so in fact, if there's even like an interruption with internet connectivity on this link, but the ONT and PoE session stays up, it does correctly detect that and will correctly fail over. It's just easier to demonstrate it on video when you physically unplug a connection, but it does reliably fail over, even if there's some sort of network outage on my main internet connection. So there we go, that's all now up and running. I've been using it for a little while, and it's been working absolutely perfectly. Since then, I've also done a couple more speed tests, and I'm now getting speeds consistently sort of in excess of 70 megabit, which for the signal strength and mobile coverage in this area is really quite impressive. The initial configuration I demonstrated has been working basically perfectly. There was only one thing I needed to change, and that was when we put the Teltonika router into bridge mode, as I mentioned, the router no longer has an internet connection itself. What this meant was this router then couldn't sync its date and time over NTP, and that went out of sync. And when it didn't have an accurate date and time, it meant it couldn't accurately collect the usage data because it didn't have a time to collect the usage against. All I ended up doing was setting up an NTP server on my MikroTik router and configuring the Teltonika router so that instead of using public NTP servers on the internet, it connects the NTP server on my MikroTik router over its local IP. And that works completely fine. This router can sync an accurate time and date, and all the data usage reporting works perfectly. Of course, you could go even further than that, and for example, connect the GPS antenna and set this up to sync its date and time over GPS. You could then even have this run an NTP server so you could get the GPS date and time on other devices on your network. I might play about with that in the future, but that's just something to bear in mind, that if you're setting this up in bridge mode, you will need to change it so that it's getting a date and time if you want to be able to use the data usage tracking. But yep, it's working brilliantly, and I'm so happy I now finally have a backup internet connection. So there you have it. That was installing a backup 5G internet connection to back up my whole home network using a Teltonika RUTC50 router. And it's working absolutely brilliantly. So hopefully you found this video interesting or potentially useful if you're considering setting up some sort of whole home backup connection. And if you're interested in buying any of the products you've seen in this video, then check out the links to them along with the discount code for MSDist in the video description and in a pinned comment. But all that's left to say now is thank you very much for watching.